going to have bariums and leads, the disposal of the chemicals you have to leave to me, right? So you can have the kids pour all of their chemicals into some jar or beaker. This would be fine. For example, it could be any container, but this would be fine. They would have to pour all of their waste into a container like this. So they would pour the waste in there as best they can with their gloved hands, and then they would use a wash bottle. Well, this one has soap in it. They would use a wash bottle that just contains water. Okay, here's one. So in your sink you have a wash bottle, and I think I brought for you 1 or 2 wash bottles also. Just with tap water or distilled water, whatever you prefer. I have a bottle of distilled water for you, and let them sort of like this. I'm gonna see if I can do this with one hand. Let them rinse their waste into the jar. All right. I will precipitate out all of the lead and all of the barium using methods that are outlined in the back of the Flynn Scientific Manual myself. All right, so there's no need for you to do that. Just label the bottle clearly as waste for Glenn, and I will come when you let me know that you're done, and I will take that away. All right. Let's see. So this box here, this box contains your metals. This little box contains this little box contains more spot plates. Ah, yes, and the metals. So I have pure copper here, so you just use a piece of this. You could put, you could try to put the iron solution on here. You could try to put the acid solution on here. See if a single replacement reaction will occur. I don't think it will occur. I think I have some iron shavings that I shaved myself for you somewhere in here. Oh, here is the lid. Here is the lid to the wash bottle that I brought for you. All right, and it has a straw, so I'll attach that after I finish this video. It goes inside the bottle. All right, now I think I have some. Yes, here we go. So this is some solid magnesium. You also have your own magnesium, so you could use that if you want. It's in the cabinet marked metals. And I have the iron. I'm really proud of the iron because I shaved it for you myself. Somewhere in here. That's the magnesium again. Okay. The iron seems to be missing here. Alright. Well, there's the lead nitrate that I mentioned, but the iron seems to be missing. So I'm going to have to go get some more. Yeah, I'm going to have to get some more iron for you, unless you have some. All right, let's see. So among your pure metals, let's see, you have aluminum, all right, and you have, oh, look, you have an iron alloy in there. Okay, that's not pure iron. Oh, wait a minute. Magnesium. You have magnesium. These look like they were made by me. You have zinc, you have copper. Now you have pure metals in here, magnesium, zinc, and copper. And you have, okay, you have calcium in here, but please do not use the calcium. It's a little reactive, unless it's old, right? Looks like you have some more zinc in here. You have some more copper. Ah, here it is. Yes, this is the zinc. I'm looking for the iron that I shaved for Arate. Is this the iron? Yes, this is the iron. Yes, this is the iron. I believe this is the iron that I'm not sure if this is the iron that I shaved for you guys, but last year. But I suggest you try this iron with the acid. You should get a reaction. Try this iron with the copper 2 chloride. You should get a reaction, right, according to the activity series. So you have the iron here. It's not me who has it. You guys have it. All right. So I made a note here last year. This is your iron shavings for magnet experiments, but this won't react with copper the way it's supposed to react, and it won't react with hydrochloric acid the way it's supposed to react either. For those reactions, you could also try the steel wool. Steel wool contains a lot of iron. Actually, I think I'm going to try it myself if I still have battery life here. So, got 1 molar hydrochloric acid, and I got some steel wool here. All right, let me see if I can get hydrogen gas to bubble out of the acid in response to a single replacement reaction with iron here. Is that reacting? Are we observing gas bubbles here? No. I am not observing gas bubbles here. Nope. No gas bubbles. Okay, so the steel wool doesn't have enough iron to do that reaction the way it is supposed to do. But let me see if this vial that I produced out of here is my pure iron. I mean, your pure iron that I made. Is this pure iron or is this some other iron? Let's see. If it's pure iron, it should do a little reaction here with the acid here. Yes, this is the pure iron. This iron. So remember, whoa, it's smelly. This is not. So it's not pure iron. There's some. I could smell some sulfur coming out of there. But this iron is pure enough to do the reactions that you needed to do for single replacement. So I'm going to leave this in your metals box. All right. This is your metals box. That's the iron that you need to use, not the other irons. Right? That iron. Okay. Thank you. Bye.